Now, coming to the types of product between vectors or the types of vector products, we know that A dot B and A cross B represents a very basic form of vector products where A dot B gives a scalar, where A dot B gives a scalar product, A cross B gives a vector product, and then we have product of three vectors, which is A dot B cross C, known as a triple product. And the triple product actually can be of two types, which is triple scalar, which comes from A dot B cross C, and we have triple vector, which comes from A cross B cross C. And again, as the name suggests, the value becomes a scalar product, and the corresponding one here becomes a vector product. All right. Now let's have a very brief overview of these three vector products. Now, like I said in the previous solution, each vector product here has its own physical significance, has its own very relevance in physics, which if I go to discuss, if I start discussing everyone in detail, then we will deviate way too much from the question here. So I don't want you to get into much of the theory here. We will solve the numerical using the mathematical, the algebraic representations, the vector algebraic representations, but I'm just giving you a hint of what these things are, the related things. All right. So cross product, represented as A cross B, results in a vector. To be more precise, results in a vector C. Results in a new vector, vector C, such that that vector is perpendicular to both vectors A and B, and the magnitude of this vector, vector C, gives the area of the parallelogram made by the vectors A and vector B respectively. The physical significance being direction of torque, angular momentum, magnetic force. Now, this is where I don't want you to go in detail. Okay, there are questions coming later in the series where direction of torque is something that we need to identify to get the correct answer, and we will discuss this cross product in detail in those questions. Now, as cross product is direction of torque, angular momentum, scalar triple product has a similar physical significance, which actually is the measurement of the three-dimensional volume in work, in checking coplanarity of vectors, so on and so forth. As I said, let us not dive much into that. Similarly, vector triple product arises in torque from magnetic force, rotating systems, vector projection correction, and there are a lot of very similar things, which most of the things that you learn in vector triple product will be in your class 12 physics. Okay, so yeah, let's not spend much time here. I would actually suggest that you make a note of this as well. Maybe assertion based or maybe a statement based question based out of these products. This will definitely help you. Make a note of this, right? Make a note of this. So pause the solution here, make a note of this, and then if you've done that, let us move on to the scalar triple product. So what is scalar triple product? If three given vectors A and B and C, and we've been asked to find out the scalar triple product A dot B cross C, to be more, this has to be A dot B cross C. Physically, it gives the volume of the parallel pipette formed by them. Now, yes, this is important, but what's even more important here is if the result of this A dot B cross C is 0, which is where we enter the question here, A dot B cross C is 0, it means that the vectors are coplanar. This implies A is equal to MB plus NC, where A lies in the plane of B and C. Yes, now, okay. I do understand that there are three totally different, points that are given to you here. But let us just stick to the first one here. Volume of the parallel pipette formed by them. So what is a parallel pipette? So it's basically a three-dimensional extension of a parallelogram. Okay. And what do we mean when by the phrase scalar volume of the parallel pipette? It means that when three vectors, vector A, vector B, and vector C, are arranged as the adjacent sides of a face of a parallel pipette, then A dot B cross C gives the volume of this parallel pipette. Okay. It's becoming it's becoming even more complex. But I try to break it down, but I think more data is making it more complex. But um, okay, now let's not go much into deep, because see, if you need to understand what is the significance of this, that itself would be a total it will be a new lecture. It's in its own right. So let us not go into that. Okay, so let's keep it simple. You have a three-dimensional figure, parallel pipette, the three vectors A dot A, B, and C. When you take this product, you get the volume of this parallel pipette. Okay, very simple. Don't well, not simple. Let us keep that simple, assuming it to be. Now, in the determinant form, A dot B cross C is determinant of AX, AY, AZ, where, okay, now what does this means? So if vector A is represented as AX I hat plus AY J hat plus AZ K hat. Oh, K caps up. And similarly, we have vector B as bx I cap plus by j cap plus bz k cap, and for vector c I cap plus k cap. The determinant of these components will give you the scalar value which represents the volume. Okay. Now, what are the given vectors? A is equal to minus xi minus xj minus 2k, in which case, what is ax minus x? What is ay minus x? What is az minus 2? What is bx minus 1? What is bx by plus 4? What is bz 3 minus 8 minus 1 and plus 3? Right? So when you express the determinant, we have minus x, minus 2, minus 1, minus 4, minus 3, and minus 8, minus 1, minus 3. Well, this has to be one single line, sorry. And how do you expand the determinant? We know first row and first column is left off. What we have is 4, 3, minus 1, comma 3, 4, 3, minus 1, comma 3, minus 6, right? So this essentially here is minus 6, which becomes plus 6 into minus 1, comma 3 and 3, comma minus 8. That's correct. Minus 2. Why is it minus 2? Because the third determinant is expanded as plus minus 2 into the cofactor. So plus into minus becomes minus 1, comma 4, minus 8, comma minus 1. Okay. And when you expand them, let us just confirm these values as well. So 4 times 3 is 12. 3 times 1 is minus 3. So 12 minus 3 is 15. Then minus 1, 3, 8 minus 3. Minus 3 times 1 is minus 3. Minus 8 times 3 is minus 24. Minus times minus is plus 24. Minus 3 is 21. Okay. Minus 8, 4 times minus 32. Okay, sorry. Minus 1 times minus 1 is plus 1. Minus 8 times 4 is minus 32. Minus 3 is plus, so 33. So what we get is A dot B cross C is equal to minus 15x plus 21 to 6, which is 126, 33 into 2, which is 66, and 126 minus 66 is 60. So A dot B cross C is, again, this is not the magnitude, this is the vector. Okay. So the dot product of these two vectors gives minus 15x plus 60. Now, it is given to us that A dot B cross C is equal to 0, and therefore this determinant has to be equal to 0. which means minus 15 x plus 60 is equal to 0, and therefore x is equal to 60 upon 15, which is equal to 4. Okay. So yes, there is another way of looking at the question.